Right, in this we're going to look at applications of differentiation. So we're going to see how to use differentiation to solve problems. So first of all, we've got this a very common problem with a rectangle. We want to try and see what the biggest rectangle you can make with 8 meters of fencing attached to this wall is what the problem's all about. So they always start in GCSE questions. They usually allow take you through it step by step, but it might be that they just say do this and get straight to the answer. But we'll look at the step by step way of doing it. So give a formula for the front of the fence. Now we know that all of this adds up to 8. We know that that will be x. Now this diagram is a little bit confusing because it's meant to be a rectangle, and I suppose they're trying to draw it in 3D. So you've got to imagine that it's x, x, y here for the fencing, and that adds up to 8. So therefore, if that adds up to 8, you've got 2x plus y equals 8, and therefore y will equal 8 minus x. Write down a formula for the area in terms of x. So if we know that the y value here equals 8 minus 2x, then we times that by the width, which is just x. So you can write it as x times 8 minus 2x, or you could write it as 8x minus 2x squared. And bear in mind, we're going to differentiate this because we want to find a maximum. And we can find maximums when the derivative are equal to 0. If you wanted to find the minimum area, again, you can find when the derivative is equal to 0. Let's carry on down through the problem. So it says find dA by dx. We'll differentiate that. We're going to get 8x will go to 8 times by the power. Minus 2 times 2 is 4. Take 1 off the power, x to the 1, that's just x. So the derivative dA by dx is 8 minus 4x. Now we want to find where it gives the largest area. So we want to find this being where this gives a max. And you get maximums when the derivative equals 0. So let's make it equal to 0. So 8 minus 4x equals 0. So 8 equals 4x, so we get 2 equals 2x. That gives you the x that gives you the largest area, but the question is always, what is the largest area? So we have to go back to the area formula up here. So we know x equals 2, so 8 times 2 is 16. 2 squared is 4 times 2 is 8. So we've got 16 minus 8, which is just 8. So that is the largest area. Now the second type of these problems is speed, velocity and acceleration problems. Now what you need to know is that, I'm sorry, that should have been distance, distance, displacement. Displacement, velocity, acceleration. So to go from displacement or distance, and displacement is better because it tells you how far you're from a point, rather, as opposed to the distance you travelled. To go from that to velocity, you differentiate. And to go from that to acceleration, again, you differentiate. And if you can remember your displaced distance time graphs, the gradient was equal to velocity, hence why you differentiate. If you've got a velocity time graph, your gradient is acceleration, hence why you differentiate. So you can find these using gradient. So we want to find the expression for the velocity, so we've got to differentiate this. So what we are finding is ds by dt is another way of saying v. Differentiate with respect to t, the bottom value. So we get t cubed is 3t squared times by the power, take 1 off the power. Times by the power, we get 14. Take 1 off 2 gives you just t to the 1. 8t just goes to 8. And numbers never affect gradient. So that is our expression for the velocity. Now to find an expression for the accelerator, we're going to differentiate again. We're going to do d dt of this. So effectively, acceleration equals dv by dt. So we do 3t squared times by the power gives you 6. Take 1 off the power just leaves you t. Here we've got 14t. If you're times it by the power, which is 1, you get 14. Take 1 off the power, you get 0. T to the 0 is 1. So it's just 14. Remember, numbers don't affect gradient. So we just get 6t plus 14. So it asks us to work out the velocity and acceleration when the time is equal to 2. When the time is equal to 2, the velocity is going to be 3 times 2 squared, 4 times 3 is 12, plus 2 times 14 is 28, plus 12 is 40, plus 8 is 48. And if you want to find the acceleration, 2 into there, 2 times 6 is 12, plus 14 is 26. Another problem. So a little bit trickier, we've got a reciprocal, and you've got to know how to write this out. So we changed the way this is written, because it makes it easier to differentiate. And that just means 12t to the minus 1. So use our same rules. We're going to differentiate to find ds by dt. What does ds by dt equal? It equals velocity. But remember that that equals velocity, because they might ask you in this form. 21, numbers do not change gradients, so ignore that. Minus 3t goes to minus 3. Here we've got a power. Times by the power, minus 1 times minus 12 is plus 12. Take 1 off the power, we get minus 2. It wants you to write it as a fraction. Therefore, this is equal to minus 3 plus 12. And minus 2 means we bring the t down underneath t squared. So you get minus 3 plus squared. It says find also where the particle stops momentarily. So that means the velocity is equal to 0. So we have 0 is equal to minus 3 plus 12 over t squared. Take the 3 to the other side. Times by t squared. You've got 3t squared equals 12. Divide by 3, t squared equals. Square root both sides, you get t will equal plus or minus 2. The only thing is you can't have a time of minus 2, so t will equal 2. You can't have negative times, not possible. So t equals 2. How from the start is the particle at this time? So put 2 back into this question. It says to 1 decimal place. Well, actually, we're going to get this exactly. Put 2 into there, we get minus 6. Put 2 into there. 12 divided by 2 is 6. So we've got minus 6 is minus 12. Take 12 off 21 and we get 9. As opposed to 1 decimal place, we put 9 meters.